And we don't need a soldering tool for this workshop, just if you hadn't soldered your IMU yet. Eric, okay, so let's get started with the workshop. Today we'll be talking about an introduction to serial communication, and then we'll follow after with our after the workshop with a hands-on game that you'll be able to create. And so here's an overview of the concepts that we'll go over today. So as you guys have all already bought, you have your IMU, and then we'll talk about that and the I2C communication protocol. We'll go over what internal sensors make up our IMU and how it's actually applied in our daily lives. Then we'll move on to using the Arduino. We'll look into the hardware component and the software aspect, where we'll both build our circuit with the IMU and then write the Arduino code in the IDE, and then see how our IMU will physically connect to our Arduino. Then finally, we will go over how to use this processing program. It's another IDE, and all it does is we'll visualize our IMU data transferred from our serial port on our computer. And so here's just like a quick demo of like what you can make. In the end, it's like a basket catching game where you control the basket with your IMU, like you can move it, you can tilt it like left, right, and then like up and down to move different directions. And then you have like random objects falling from the sky as well as a score. And so this is just our system overview of what we'll be creating later on today. So first, you'll send your IMU sensor values to your Arduino by physically wiring them up and writing a simple program. And as you can see, we're going to use the I2C serial communication protocol to send that IMU data to our Arduino MCU. And so our IMU is going to act as our like tilt-based controller that we'll use for our game. And so after we send data from our IMU to our Arduino, we send that data from our Arduino to our laptop using the serial port, and you'll be able to access the information on that serial port in your processing program, and we'll walk you through how to do that later on. And then finally, once we get that IMU data on our laptop, we can create our game through an application called processing. And this is just an IDE where you're able to create like really cool graphics and visuals for your game, which the Arduino can't really provide. And we can visualize the IMU data by mapping it to a controller on your game screen, hence the name IMU tilt-based game controller. And so if there's any questions about like what we're doing throughout our workshop today, like feel free to interrupt because it's a lot of information and we're here to answer all your questions.
All right, so I guess a good place to start is with the IMU. We've been using that term a lot, and it's one of the things that we had you buy for this workshop. So you might have kind of been wondering what it stands for, first of all. And so what it stands for is just inertial measurement unit. And that sounds kind of fancy, but we can really sort of boil it down to a motion sensing unit. Now, I think a really good background for this is perhaps if you've taken E96C with Professor Kaiser, because a lot of the similar things go on there. They've got a sensor tile that works in sort of a similar fashion because it has different kinds of sensors that perform different functions like this IMU does. Now, one of those is the gyro or gyroscope. And so what this does is it will report rotational velocity at a given time around one of the axes of the IMU. And really cool thing about this is that we can get the angle that it's rotated if we integrate with respect over its velocity with respect to its angle at any time. So another thing that the IMU has on it is an accelerometer, and this is somewhat a little bit more simple to think about than our gyro. It's just moving in one direction or another, and it does this by measuring acceleration. And if we wanted to, we could use some trig math to calculate the angle that it moves over, but we can oftentimes just use the gyro for that. So what the IMU does for us is it will transmit data about a device's movement, and whether that's speed, direction, orientation, or velocity, It'll transmit that to whatever device we want to give it to. In our case, it's going to be an Arduino. And so the cool thing that we can use it for, that we're going to use it for in this project, is we're going to use it to detect motions so that we can control our game. So for this workshop, we're going to be using the IMU measurements about the X and Y axis, but not the internal Z axis. And if you picture the motions that we were going to make and that you saw Jackie making in the demo, I think you can probably picture why this is. All right, so next we're going to think about some applications of the IMU in real life. And one of those is in drones. I don't know if any of you have taken aircopter, but you're probably aware of the project. And so they use a very similar thing to determine what direction that the drone is tilting so they can do corrections, which is a very important thing for the stability of your drone. And also, this is a bit of a throwback. I don't know if people still use Wii, but way back in the day, if you were playing your Mario Kart with one of those Wii controllers, it used one of those motion sensors in it to see when you were turning. So those are just a couple cool real world applications of IMUs. So the next bit of hardware that we had you order was the Arduino. And a lot of you are probably a little bit familiar with Arduinos because they're the first multiprocessor, microprocessor boards that a lot of people use when they're getting into electronics. But we'll just go over the basics of what they do. So first of all, Arduino boards, they're microprocessors that are able to read inputs and their variety of pins. They can turn it into outputs, which they also send through a variety of pins. And those inputs can be many things. You may have seen these Wall-E sensors before, like on the bottom left that look like eyes. So those like infrared sensors that can return a value to the Arduino, which you can use to discover how close or far objects are away. There's also keypads, which give certain inputs at any given time to record a value. And then my favorite, which is the joystick right here, which is also really cool. And then they can take those inputs and give them as outputs to something else. For instance, if you had a keypad, you could have it give letter outputs to a display like this. If it was perhaps motions on the joystick, you could interpret that into motions on your stepper motor. And maybe if you had a microphone input, you could change the signal in your Arduino and then output that to a speaker. So Arduinos are great for a lot of stuff. And this is just the basic structure of our project, like we mentioned a little bit before. But we're going to get our input in the IMU. We're going to shovel that into the Arduino, mess with it a little bit, and then put it back out into our computer where we have the processor that will output our game. So let's look a little bit at some of the connections that are on our Arduino. These are going to be important for a little bit later. So we're going to want to connect our circuit to a couple analog pins, and I believe we'll also need some power pins, which we think of as digital, like our 5-volt and ground. And the pins that we're going to be using today for our communication between the Arduino and the IMU are pins A4 and A5. These are also our I2C pins. We'll get into a little bit more of what that means later, but you can see in the diagram on the left side of the Arduino where those two pins are. And now there's also going to be a software component that we're going to have to do because we're going to have to deal with the input that our computer is getting from the Arduino and also deal with the input that our Arduino is getting from the IMU. And we're going to have to handle the logic of how that should work to create our game properly. So our next step is we're going to have to think about how exactly our Arduino and our IMU are going to communicate. I think we know if you've either taken maybe CS33 or M51 or M16, you'll be familiar with the fact that electronic devices always communicate using bits, which are just streams of ones and zeros. And it's the same kind of thing going on right here. We use binary bits to send our messages, and they carry all the information that we need to pass from one device to another. The big question is going to be, of course, how do we interpret these bits? Because if we don't have an interpretation strategy or protocol, then it's just a bunch of ones and zeros, and that's not what we want. So that's where our I2C or I2C communication protocol comes in. Our IMU is going to be constantly turning in a bunch of bits like this, and we need some way that we can interpret it. It's sort of like the alphabet is to English. We have a bunch of different letters that form all the words that we need to talk. And in binary, we have a bunch of different combinations of ones and zeros that are interpreted by I2C into meaningful language. Another thing that's important about our Arduino and IMU is talking about the structure of I2C as a protocol, and that is a master-slave architecture. This is a very common architecture in all kinds of electronics and computer science, and it basically just means this, that there is one master or controller that is connected to a bunch of slaves or lesser branches that can return or get sent information. Now, in our case, it's going to be a little bit less complicated because we actually only have one slave at a time, which will be our IMU, to one master, which is our Arduino. Now, this communication is done through two lines, and one of those lines is a data line, and one of them is a clock line. So we'll go into why we only have one line in a moment. But you can see how the connections work right here. We've got a master that's passing data along its data line, or the slave is passing data along the data line, and then the clock that is clocking the transitions between the bits. So I mentioned that I2C is a communication protocol, and more specifically, it's what's called a serial communication protocol. So back in the old days, what they used to do was parallel communication, and that would basically mean you'd have, say, 8 wires next to each other connecting one device to another one. And so those 8 wires could pass 8 bits anytime, or a byte of data across. Each time a clock hit high, for instance, then the data would be read by one or the other device. But this is very space inefficient. So people wanted to see if there was a way that they could, instead of having all these parallel wires running with each other, if they could have a single wire to pass all that data. And that's where serial communication comes in. So in serial communication, a single bit is transmitted at a time, and I2C is a serial communication protocol. And if you're interested, that stands for inter-integrated circuit, which is kind of a weird name, but here we are. At the bottom right here, you can see an example of an I2C message or communication, and we'll go over what each of those individual parts means. So first of all, we've got the start condition, which is relatively self-explanatory. The start condition is just an indicator that we're about to have some data transfer. And so how this happens is that the master device, it pulls the SDA line low. And so the SDA line is usually high or usually at 1. But when we want to start, we send that signal out by pulling that line down so that the slaves know to expect something. So our next step is going to be the address frame, because as we mentioned before, a master can have multiple slaves. And so we might not want to communicate with all of them at a time. In fact, we usually don't. If we got a bunch of slaves passing data along the same line at the same time, we get a bunch of issues. None of our data would be good. So we want to specify a particular slave that we want to communicate data with. And that's done using the address frame. And in addition to that, there is 1 bit afterwards, after that 7 to 10 bit address frame, and that extra bit specifies whether we want to read from the slave or whether we want to write to the slave. So our next step is a ACK bit, and this may seem a little like a weird name, but it's really just short for acknowledge. I don't even think there's like an acronym for it. It just means acknowledge. And this is just if we have a slave with the correct address, because say for instance, our master made a mistake and sent out a wrong address, this ACK bit lets us know whether or not that slave is actually out there. So it returns a correct bit if the correct address has been found. And it does this by pulling the SDA line low for 1 bit. So just like earlier, the master pulled the SDA line low as a start bit. Now the slave is pulling the SDA line low to acknowledge that it's received the address. Our next step then is the actual data part, which is the big thing. This is the important part. And how it does this is we'll simply send a data frame at a time. And say, for instance, that could be 8 bits or 1 byte. And it's important that we have this data frame be relatively short and then with an acknowledge bit afterwards so that we know if our communication protocol ever gets off. Because if we ever run into a circumstance where an acknowledge bit is not received after our data is sent, we'll know that something's wrong and we can't trust the data that we're getting anymore and to stop the protocol. So yeah, after each data frame is transferred, the receiving device will send an ACK bit to the sender to acknowledge successful receipt of the frame. And then after that, we can keep on sending data for as long as we want to. Here we've only got 2 data frames, but it can be pretty much continuous if we want that to be the case. And I think that's pretty much what we're doing here on our project. All right, and finally, we've got the stop bit. And this is just simply to stop the data transmission, and the master is in control of this. The slave cannot be in control of it. And so what the master will do is simply switch the clock high before switching SDA high. And this combination of signals will indicate to the slave that transmission can stop. And there we go. That's the fundamentals of I2C. That's how data is passed between our master and our slave, and that's what we're going to be doing today. So let's go over all that again a little bit, but in a sort of more high-level sense, just so you can get a bit of a feeling for how it goes. And I think one of the greatest ways that people can really understand concepts in electronics or computer science is through metaphor. So here's a metaphor for what's happening at each stage in our I2C protocol. So that start condition that we mentioned before, the master just pulling STA line down, that's like person A, the main person in our conversation, says hello. And now, of course, if somebody just says hello in a room full of crowded people, we don't know who they're talking to. So the next part is really important. It's calling the slave's address, or in our case, it's person A giving somebody's name. So we specify who exactly we want to talk to. Now, the next step in the conversation is going to be whether or not we want to tell the person something or we want them to tell us something. And so that's where our read-write bit comes in. So after that, we want to make sure that the person is actually hearing us, has actually heard what we have to say, or else nothing's going to happen productive further in the conversation. So we wait for that acknowledgement. So person B, the person you're talking to, says, okay, or they say that they couldn't hear what you were saying. And so it's important to know either way. Now, assuming they said okay, our next step is to do the actual messaging part. And so this is where we exchange info, where person B tells me something, or I tell person B something. And then we can keep on going for that as long as we receive responses from the person, because if they stop responding, it's a pretty good indication that they no longer care or can no longer hear us. And finally, the part that isn't usually like normal conversations, unless you're kind of rude, is I say to the person, okay, I don't want to talk to you anymore, I'm out of here. And then I end the conversation. So that's I2C for you. Okay, so this is our question for an Amazon gift card today. I want you to type in the chat. I want you to explain the process from start to finish about how the master sends a message to a particular slave. So this is about completeness as well, so not just quickness. See if you can get a complete answer in before anybody else.
No copy and pasting too.
Bit of an essay question here, isn't it?
It is. It's not just one word anymore. We'll just take a couple of minutes so someone sends an answer.
I like the completeness of Dominic's answer, I think.
I also agree, but very good explanation as well, Preston.
Yes.
I think this week's gift card will go to Dominic. And
although we do have a Kahoot right around the corner though, so
that's true.
you'll have a chance. Okay, I think
You'll
that's
be able
actually
to
next.
Mhm.
That's next. All right, I'm gonna stop my share real quick and I'll start that. And let's see. Share my screen again. All right, we want player versus player, as I recall. Loading game pin. There we go. Taking that down a bit. All right, guys, let's see if we can join up the coot. This will also be for an Amazon gift card, if we weren't clear about that before. All right, I think we still need 2 more people. So we'll give you guys another minute to do that.
Desmond's out for the dough. He sent a money emoji.
I like it. All right, guys, we still need 2 more people, so we'll give you another 30 seconds or so to do that. At least that. All right, I guess we will start. Okay, let's do this. All right, first question. What serial communication protocol did we learn today? All right, good
Wow,
answer. Good answer.
everyone got it.
I just want to see if you're paying attention. Okay, let's see.
Oh yeah, next.
There's next. Okay. I had people's faces covering my next button. Okay, there we go. What are the 2 lines used in the I2C protocol? This one's a little bit harder, but not too hard for you guys. Yes, SDAN.
Not hard for everyone here.
All right, so that means we got Preston still on top, but David and Eric rising up. What are the sensors that make up an IMU? All right, very nice.
Wow.
Everybody's still 100%.
I think I made it too easy.
I guess we'll see. All right, we've got Preston still on top, but barely. Disney's on fire, catching up.
Everyone's on fire.
What are the 2 functions inside every Arduino program? Ooh, this is good because we haven't really covered this yet. But hey, everybody knows their Arduino.
Everyone still knows.
All
Really
right.
nice.
Ooh, yeah. Preston knocked off his throne and Desmond's on top.
Desmond.
Going for that dough. All right, true or false right here. The IMU we are using uses SPI, serial communication. Ooh, this was the one that divided men from boys. Interesting. Yeah, we're using I2C, so not SPI. That's another kind of serial communication. And we still have Desmond on top. All right, what is at the beginning of every I2C message? Yes, that's correct. We have a start condition at the beginning of every I2C message because, of course, the master has to let the slaves know that we're going to communicate now. He initiates the conversation. All right, we still got Desmond on top, Preston rising up again. How does the master let which slave know it wants to talk to it? Yes, we broadcast the slave's address, so there's no possibility for confusion. And Desmond
Everyone's
maintains
killing it.
Yes, very good job, guys. Just got a few more questions here, or 2 more questions. What does the ACK bit do? Yes, the ACK bit or acknowledge bit lets the slave know the master has received the message. Okay, so we still got Desmond on top. One last chance for people to knock Desmond off. What does every I2C message end with? All right, yes, it's correct. We need a stop condition so that we know we are done. All right, let's see who is on the podium. Very nice, David. Pressed in a second. Let me guess who's on top. Desmond. All right, very nice, very nice. You weren't lying in the chat beforehand. All right, good job, guys. Let's stop the share.
And then I should have all of your email addresses, so I'll send you guys the gift cards afterwards. And now I shall share my screen. Hopefully you guys can see this. Can you guys see my screen?
Looks good.
Okay, thank you. I also can't see like the chat that well because I'm sharing my screen, but the very first thing we're going to do is wire our IMU to the Arduino. So what we have here is we have the 5 volts from our Arduino connected to VCC of our IMU, and then ground connected to the ground of the Arduino. And we just have like the 2 I2C data lines, SCL and SDA. So SCL corresponds to A5 and SDA corresponds to A4 on the Arduino. And then once you're like done with that, or if you have any problems, like please let me know in the chat. Also, like feel free to like turn on your your cameras now so I can see like if the wiring is correct or if there's any problems. Corwin, your breadboard's being used for your Arduino. Well, you gotta throw away your Arduino. Just kidding. Do you have, so you don't have any spare ones, Corwin?
No, I do not have a spare breadboard lying around.
Do you think
Unfortunately.
you can like, so you have your Arduino Nano on your Arduino?
Huh? What? Oh, you want me to put it onto the car? I mean, I guess. I have a little bit of empty space. I guess it could fit.
Yeah, if you could just put like some like empty space, and then I don't know if you need to disconnect anything else or just like the
Yeah.
wires.
No, Preston, I don't have any extra of those wires lying around. But yeah, I'll just put it onto the car. And it's gonna be kind of ghetto because I'll be like carrying a car around, but I guess it works, you know.
Honestly, that adds a whole new dimension to the game if you're driving around a car to make things happen.
That is true. That's fair. Yeah.
Yeah, please like let us know in the chat once you're done wiring it up.
Yes.
All right, great job, Juan, on wiring that up. And also, like, it doesn't have to be an Arduino Nano. You could use like an Arduino Uno if like you have that lying around as well.
Yeah, I'm using an Arduino. Is that
You're
Rebecca?
using, yeah, it's like totally fine. All right, awesome job, Desmond.
Who does?
Okay, so while we're waiting for the others to finish wiring it up, there's some links that you need to download. If you've never downloaded the Arduino IDE, you need to use this link right here. It'll take you to this page. Sorry, this is taking like a little while for me. And then you'll select whether like you have Windows or Mac. And then if you like bought it off of the, so here's Mac and then like Windows. And then if you bought the Arduino Nano off the website I gave, since it was like really cheap, it means like it's like a knockoff Chinese brand. So like
Mhm.
Here's like a driver that you may need to download right here. And it's like in Chinese at first, but you can just Google translate it. So like to English, but it's like not really necessary. And then you'll see that you have, this one's for Windows. So this is a Windows driver that you need to download. And this is a Mac driver that you need to download. And then once you're finished doing that, you would either need to restart your Arduino or your laptop or computer for like the driver to actually work. And then basically the reason why like you need this driver is so that the port can actually show up in your Arduino IDE settings, and we'll show that a little bit later. And then finally, we have our processing program. So you just click on this link and then you just select whether you have Windows or Mac. I don't know if like anyone has like Linux here, so if you do, like feel free to select that.
I would be impressed.
Okay, so yes, please like also let me know. Preston, did you already have like an Arduino Nano or Uno since you're in ops, I believe? You won't need to restart if you already have it. Yeah, just use your Arduino Uno.
Also, they should try just restarting the Arduino IDE, right? First before.
Yeah,
restarting the
try
computer.
restarting
Yeah.
your Arduino IDE first.
Hopefully the whole computer restart won't be necessary, because then you'd have to leave and rejoin the meeting. It'd be very sad to see you go.
Very sad. Okay, and then everyone else, like, please let me know in the chat once you've downloaded all the necessary applications.
Yeah, keep us posted, because otherwise we don't have any idea how fast you're going.
Yeah, we can't see some of your faces, so we're relying
Sure.
on the chat.
Or feel free to turn on your camera, unmute yourself, converse.
I'll give you 2 cents if you turn on your camera and Venmo you.
There's one.
Oh, okay.
2 cents is an offer I couldn't pass.
This is what I like to see. Okay, so everyone else who has their camera on, I'll Venmo you 2 cents. You can actually you can Venmo request me at teriyaki. This is my Venmo
Don't
handle.
worry about it. Teriyaki, that's your Venmo.
Yeah.
Teriyaki, that's pretty funny.
Well, people want that 2 cents. Okay. Did you
Why
guys
teriyaki?
it sounds like teriyaki sauce, but like it's yaki at the end, like Jackie. So
No, I get the rhyme.
Oh,
Do you actually like teriyaki chicken? Like, do you actually like teriyaki sauce?
oh no, I don't really eat it. I actually don't
What?
really eat anything.
That's a plot twist right there.
Did you get your thing downloaded, Juan?
I already
Okay.
had it because for one of the Arduino experiments, you kind of used it.
Okay. Sounds good. And then, okay, I'll just move on so we don't spend too much time. All right, and then here's the Arduino IDE. Let me just present this. Sorry, it's still loading. Okay, so once you create an Arduino IDE sketch, this is the 2 functions that will appear by default is your setup and your loop, and all your Arduino programs are based on like C++ syntax. So if you're like familiar with that, this should be pretty simple. In your Arduino program, what you would want to include in the top are these two header files. I'll have like a copy and paste code that you'll be able to put in. So don't worry about like this too much about this for now. In our setup, we set our pin to be an input or an output, typically, and then we would set our baud rate. So serial.begin 9600 means we want to transmit at 9600 bits per second. And then initialization, so whatever you want to run once in our setup, you'll put there. And then something specific to our IMU, using like these header files is this function IMU setup. That's like, you just need to call that if you've included these files, and there shouldn't be an error. And then we declare these three variables, IMUX, IMUY, and IMUZ, which indicate like the direction or like values of your IMU in the X, Y, and Z direction. And these are variables that are accessed through, that can be accessed through like this file, imu.h, and it's updated every single time you call IMU loop. And so in like our loop function, this is going to run indefinitely, and this is where like kind of like the meat of our code is going to be. This is typically where we'll read our IMU sensor indefinitely using this IMU loop function. And so every time we call IMU loop, these three variables, IMUX, IMUY, and IMUZ, will be updated. And then we can use a function serial.print. There's an ln at the end if you want it on a new line, and then whatever value you want in there. It can be like a string or an integer, and then it'll print to your serial monitor. And then our first exercise is to actually just like print out the raw IME values. So make sure you also download the library for the IMU here at this link, and then we're going to upload that library to the Arduino. And then I'll do that like with you, so it's like you can follow along. Okay, so it's called sensorfusion.zip, and then you just want to click on it and then download it. I already have it downloaded, and then you want to open up your Arduino program.
You have to download both files because I see two.
So it's a zip file, so it was just download as one file, and then I'll show you how to include the zip file in the Arduino ID.
Okay.
So if you just click on this like download button right here, it should download everything. Okay, and then now if you want to import the library, you're going to go on Sketch and then include library and then add .zip library. And then you can just go through wherever you downloaded it. So I'd go. I found it. So I have sensorfusion.zip, then I would click on that and then I'll put choose. And then I already have it like already imported, so that's why it has an error right there. And so once you have like this step, can you like please let me know in the chat or just like unmute.
Remember the first coding you ever did, Jackie?
Do I remember the very first what?
Coding you ever did?
Hello World?
Mhm.
It's actually the very first one I did.
My
How
first
about
was
you?
my first was actually a Blinky program on one of these Arduinos. Just got memories looking at the idea again.
Oh, you meant on the Arduino?
I meant just in general, but that was actually the first coding thing I ever did. For some reason, that was where I started.
You were meant to be EE, but actually you're CS.
Yes. I
Did
was
you
meant to
guys
start out.
scratch the IO? No.
Yeah.
Scratch? Yeah.
Oh, on Scratch? Actually never knew. Wait, is that what you said, Corin?
Yeah.
I actually never like used Scratch before, but I had to teach it to like little kids. Little kids are like going off on CS. Like 9 to 12-year-olds, they're learning Scratch already.
That scares me.
I
They're
remember
gonna be
using
hackers.
Scratch in middle school. It was quite fun.
9 to 12-year-olds are learning to code now. They're going to be so much better than us in 10 years.
You know, like when they reach our age, they're gonna be hackers. And then that's why we have a data breach in our social security numbers on the dark web.
Thanks, UCLA.
Oh. Did anyone else get like, was anyone else like a victim of like it? And they checked on Experian?
I've checked.
I never did the Experian thing, but maybe I should.
You should do it. It monitors your email and like it looks at like all the data breaches that like you sign up with your email.
Does it
Like,
take a
on the
while
website?
to set
No,
up?
it's like super quick.
Okay, I'll look into that.
Yeah, just look at the UCO email.
I'm trying to Experian. They already had a data breach too.
Oh yeah.
Yeah, they did like a couple of years ago. They already had a data breach. So I'm like, I don't have to trust you.
Yeah,
no good
and
options.
their breach was, I think their breach was like half of the credit cards of the United States, like half of the information of all the population in the United States it's already out. Yeah.
It's bad news.
Okay. Was everyone able to import the .zip library? Can you like please like nod your head or something? Okay, perfect. All right, now we can actually print out our IMU values. So you want to go on file and then new sketch. It's really hard to share my screen at the same time. So file, new, and then just copy and paste the code that's like in the slide. And then what you will need to fill in are these 3 highlighted texts, and it should be a hint on what line it is and what you're printing out using the serial.print. And so can someone in the chat like write down what we should fill these 3 areas with? What variable?
Isn't it just IMU dash? Yeah.
IMU X, Y, and Z. Okay, I already have it over here, so I'm gonna delete that. And then now I'm going to plug in my IMU and Arduino to my laptop first. And then I should be able to go on tools. If you have the Arduino like Sketchy Nano that we have, you might have to like click on processor and old bootloader for it to actually work. And then make sure your board is selected to Arduino Nano or Arduino Uno. And then your port should be something like, if it's a Mac, it's like USB serial and then followed by a number. And then if it's Windows, it should be like COM something. So I have this, and then I'm going to upload it right now.
Where do you find that old bootloader setting you're talking about? Because I have that Arduino. I can switch to another Arduino though. I don't know.
Sorry, you don't have that option, or you do have the option?
What do you mean? Wait, can I see where do you get that option again?
You go on tools, and then processor, and then it should show up as old bootloader.
I do not see processor in my tools menu.
Maybe if you look through like the other tabs, it should show up. It's like where all you have your like your entire board information is, like the settings.
You have board and port under there?
Yeah, I do.
Interesting.
And what the board should be just Arduino Nano, right? Yeah.
Sure.
Okay. I may just switch to an Arduino Uno because I don't know. I might need to like restart my computer or something for it to work. I don't know.
Okay, yeah, maybe
Weren't you guys
try
saying
to
that?
maybe try to get your Arduino Uno,
Okay.
and then I can try to like help you after like the workshop to like just configure the Nano so you can use it like for the future.
Okay, sure. Thanks.
Okay. And then now if I click on the
Where did
serial
you go,
monitor.
Jackie? I kind of missed it. Where did you?
Oh, I just uploaded the program. So I click
Oh,
on upload, and then I open up my serial monitor by clicking on this little icon, and this should show up. And then as I like move it like forward, so I actually can't see myself. So if I move it, if I have the IMU kind of face like upwards like that with like the LED at the bottom, if I move it up and down like this, that should correspond to like my Y values. As you can see, it's going from negative, it should reach negative like 100, and then 100 is the range for X, Y, and Z values. And then if I move my IMU like kind of like left and right, that corresponds to my X. Sorry, my Y
why
is not
is
that long.
well, I mean, yours looks so slow compared to mine.
Just be the-
It might be Zoom, like it's like laggy also.
How do you add a new
slow.
line? Because for me, I forgot mine doesn't like.
Sorry, can you repeat that one more time?
How do you? What is it for a new line? Because for me, it's just like printing to the side. I forgot how do you do it?
Oh, it's printing on the same line for you.
Yeah.
Did you copy the same exact
There
code?
you go. I just typed it. I forgot. Just airline. There you go. Like I knew I just had to add like some airline somewhere, but I didn't know.
Okay.
I imagine that was a pretty long line then.
It was getting pretty long.
Can I get like a thumbs up like reaction if you got this far and was able to print out values?
Got a thumbs
And
up
it
from
like,
Kristen.
okay. And it actually changes when you kind of move it around. Okay. Awesome. You guys are so good.
Can you repeat how you changed the Y value?
Oh, okay. So if I have like my LED right here,
Yeah.
and then I face it like flat like this, if I move it up and down, so that's our Y value is changing. Like, see, it's fluctuating between like 100 and negative 99 or negative 100. But then if I move it left and right, that's our X value. We don't really care about the Z value right now because we're gonna use it for like a game controller that it's like a 2D game. So you only need like 2 axes.
Yeah, because so far only my X and Z value are changing. My Y seems to stay the same.
Do you have your wires connected correctly on SCL and SDA?
I think so.
Do you have? Here, let me
Okay, never mind. Yeah, it starts to work.
Oh, cool.
Oh, it's starting. Okay.
Right.
Yeah, sometimes like it might get like stuck, or like you might have trouble like uploading to your Arduino, and so you just like disconnect and reconnect it back again. Okay, so now you should have something like this. Sorry, it's taking a little while. Okay, so it should just be like that as I move it around. And now we're going to talk about why we want to use the processing IDE. So Arduino, as you can see, you don't really want to just print out values. It's kind of boring. But if you want to make a game and provide graphics for your IMU values, this is what our processing program is going to do for us. So the processing IDE, as you can see, it looks like very, very similar to your Arduino one. It's just like a different color. And it's also based on Java, which is actually pretty similar in syntax to like C++. So you shouldn't have like too much trouble on transferring that information, but I'll also help guide you and also code along with you so that you get up to speed on using the processing IDE because it's a little bit different. So we have a text editor, we have a console that prints out an output, a compiler, and it will also run our program at the same time. And then it will create a display window right when we click on run. And then let's continue. Yeah, so we have our text editor, console, and then run and stop. And so here are the main functions for our processing IDE. So we have void setup, same thing as Arduino. It runs only once in the very beginning of a program, except what we do in the setup. Since we're focused on graphics in the processing IDE, we want to initialize the display size of our window. And then we have our draw function, which is like the same exact thing as our Arduino's loop function. It's going to update the display window continuously in case there are any updates throughout your program. And then it just redraws our graphics every iteration of the draw loop. And it's going to run indefinitely, and it's just going to render any updates you put into your program. And so continuing on, like we said, our size is going to set the size of our processing window. We're going to just input it into our setup. So in this case, we have size takes in 2 parameters, a width and a height. We just set it to 500 by 500 pixels. And then there's another function called color, which returns a color object, and it's just based on RGB values. And RGB values you can look up like online, like a RGB color picker to get any values. And it ranges from value 0 to 255. And so we created the color pink over here on the right. The RGB value 255, 102, and 255 corresponds to the color pink. And then if we want to set the background color of our display window, we will call this function background within our draw function. So it's just like basically going to clear our display window at the beginning of each frame that's rendered. And so I'll go back a little. After we run this little sketch right here, what we should get is this window. You see it's 500 by 500 pixels. The background is pink, and that is it. And so now we want to make some shapes because obviously our game is going to have some kind of object falling from the sky as well, like as our basket to catch the objects. So we have this function called fill, which takes in the parameter color, and it sets the color used to fill shapes and all the subsequent shapes. So if you run the function fill and then pass in orange, all the shapes after that function will be filled with orange until you call fill again. So it's just setting the current color of the object. Then our next function is rect, and all it does is draw a rectangle on your screen. And by default, the first two parameters, x and y, which are just the coordinates of your rectangle, it corresponds to the location of the upper left corner of your rectangle. So if you have like 0, 0 of your rectangle, it's going to correspond to the upper left. But if you want to change the coordinate so it's actually in the middle or the center of your rectangle, you want to call this function rect mode and then center. And so as you can see over here, we have two colors, pink and blue. And then our setup, we also set the display window to be 500 by 500. We set the background color to be pink, and then we just create a rectangle that's blue by calling the fill function, setting the rect mode to be center, and then calling the rect function width divided by 2, height divided by 2, and that just indicates the center of our screen. And then the width and the height of a rectangle to be 200 by 200. So when I click run, it should give me this screen. So now we're going to connect both the Arduino and the processing program together. We're going to take our IMU values from Arduino, send it to our laptop, which is running our processing program. And so this is our third exercise. We want to find the right serial port. Let me minimize this. The right serial port that Arduino is actually connected to so that we can use that same one in our processing program. So if you can copy this code right here, not this part right here, copy from import serial libraries all the way to this closing bracket, and then open up a processing program. And then paste it in there. You should, after you run this program, you should have this output of like all the different serial ports that your laptop has. In this case, or in this example, sorry, you can't see my screen yet. I use the port 39, but it will be different for you. So make sure you run this code first, and then we're going to wait for everyone to be able to find the right serial port. Sorry, it takes like a little while to load. Okay. Okay, so now I'm going to copy and paste this. And then when I click on run, it's probably going to ask me to save this first. Whoops. Okay. Because I have a serial port, I didn't actually do that. So after calling print array serial.list, it should print out like a list of all the serial ports that you have. And then looking at my Arduino, port, the Arduino is connected to, for the Macs, it's cu.usb serial 1410. And then I want to select the TTY option because Arduino is sending information while our processing program is receiving it. So it needs to be the serial port for Max. It's TTY and then USB serial, not this CU one. And then once you have, so make sure you take note of this index 3. So if I replace 39, like that was my previous index, this should run smoothly and not have any errors. And so yeah, I don't have any errors there. And once you get to this step, feel free to let me know by like doing a thumbs up. A thumbs up reaction. All right, awesome, Eric, Preston, Dominic. Okay, awesome. Okay, and then we'll move on to the next step. So now we want to print out the IMU values from our Arduino onto our processing console. So what we want to do is add this function right here. It's called serial event. It's kind of a built-in function already. And all you need to do is copy and paste this somewhere into your processing program. And what this does is looks at if my port.available is greater than 0. That just sees if there's any information on your serial port at that point. And then it sets your input string that we declared up here to read all that information until it sees a new line. And then it just prints out that information to your console. So I can copy and paste this. And then I'm going to put it in here. And then make sure you change your port number to port index to whichever corresponds to your Arduino. Then I am going to run it and hopefully it prints out the values. Okay, so now you can see like all the values on my processing console. And if I tilt it, it should be changing corresponding to like our Arduino serial monitor. And so once you reach this step, please like react with the thumbs up. And then by default, this like little display window is like created since I didn't create it specifically in my program. All right, so we got 1 thumbs up. I'm gonna wait for a couple more. Okay, awesome. All right, and then I'm gonna just X that out, which will stop our program. And then now you're going to test out this template game just so you have an idea of how it should work theoretically. So click on this link and then download the zip file there. So it's workshop IMU game.zip. And then after you unzip it, you want to run the workshop IMU .pde file. And I'll just show you how to do that really quick. Actually, I think I have. Okay, so I might type it here. All right, so once you unzip it, you should get workshop IMU game. You click on that and then you select this file to open, not the other ones. And I'll show you what the other files actually do. All right, so here's our code for the game. And here's a couple of files. There's a file called colors, which literally just declare like global variables that you can use throughout your other files. So you don't have to like call them each time, the function each time. This is just an object class, very similar to like a C++ class, which is just an object that's falling from the sky in our game. As you can see, we have p vector. You don't have to use this, but this is just indicating our coordinate x and y of our object, and then we have a width and height. You don't need to like understand this right now because we're going to go over the steps from scratch, but here's like a game basket class. And then once you run this, sometimes it will give like an error, but you just need to like unplug your Arduino and then plug it back in. Hopefully it works on the first time. Okay. I don't know if you can see my screen. It might be a little bit laggy, but like as I move it, it should be like catching these like little squares or balls, and they're all like moving at random speeds or being generated randomly like in the sky. And so like there's a score that's being updated or incremented each time our square kind of passes through our object. And so also once you reach this point and are able to run this, please give me a thumbs up.
It's not running. Like I open it, I run it, it says cannot find a class or type name basket.
Did you download all of the files or all
All
of
of them
the
are,
entire?
yeah, but all of them are open. Like I opened the workshop IMU, but that's the only like thing that's open.
Can
I
you
don't have them
open?
one next to each. All of them?
So when you
They
open
open
up
like in different.
the folder, when you clicked on file open, did you click on the workshop IMU game?
Yep.
Like this, and then open it.
I'm trying. I'm opening them one at a time. They're opening together.
Oh, don't open these. These are just like other files that are used within this main workshop IMU game.
Looks like Preston got an error as well. It says
Okay.
error disabling serial event for COM11 null.
Also make sure that you close the serial monitor on your Arduino as well. And then once you do that, yeah, sometimes it will give you like an error because like it's like still transmitting like all the IMU values. And then like when you run it, sometimes it interrupts that process. But if you
So
just
should
like
I close
unplug. Sorry,
I
go ahead.
close the other program that we did for the knowing which port was it, or should we keep that one open?
Oh, you can close that. The only thing that you need right now is like this open right now, because the other one is just using the port. Like you just need the port index because everyone has a different index, and that's why we did that. All right. Okay. Anyone else get it to work or not working?
Still not working.
What does it say on the error again?
For me, it says array index out of bounds exception 39.
Oh,
I need to
did
change
you
the port name,
replace?
huh?
Yeah, replace this.
It's always a good sign when the error changes.
That is true.
Oh,
And then sometimes there might be like an error if you still run it and then it'll say like serial port like busy or like some kind of error. Just like try to rerun the program and then unplug your Arduino and then plug back in. Okay. Did you get it to work, Juan?
It works now. Yep.
All right, awesome. Okay, I'm gonna continue now with the action. Okay. So now it is your turn to recreate the game. And so the first step that you want to do is actually just map the IMU value to your basket location within the game. And so you're going to create the controller and parse the input to get the X and Y values of like IMU X and IMU Y that's printed out on like your serial monitor, and then map it to the coordinate of our rectangular controller. And a really useful function that you might find is using this map. It's the same one in like Arduino, where the first parameter is the variable that you want to map, and then the second and third parameters are your minimum and maximum range of this current value, and then where you want to map it to. So right now we have the range from -100 to 100 for like our IMU X and IMU Y. And then we want to map it to our game screen, and what the keywords that you can use like in your program are width and height. And then I'll show you how to do that using this skeleton code. So this is just like to start you off with like the different parts. So this is part 1, and you want to open up part 1 of this. Okay. Okay. So then I have this, then part 1. Then I'll X this out. So first we have all of this. Our string input is whatever we read from our serial port. Our port name is and my port are just going to be what we had before, where we initialize our serial port from our Arduino. This random object is just so we can generate a random number, and we'll see why this is useful later on for our object being randomly generated at various points at the top. We have our basket configuration. So I just arbitrarily set basket width to 100 pixels and height of 40. And then I set the basket color to this value right here. I believe it's like yellow. And then I just declared the variables from our IMU that we will be able to use later on. And then we have our mapped coordinates of our basket on their screen. And so this function right here, all it does is parse through that string that goes like X colon, and then the IMU X value, and then Y colon, IMU Y value, and then Z colon, the IMU Z value. And it just parses through that and saves only those numbers into these 3 variables, IMU X, IMU Y, and IMU Z. You don't need to like you can just copy this function right here unless you want to like do it on your own later on. And then I can explain the code to you, but for now you can just copy this parse int function. And then going down, this is our serial events, event where we just read our input the serial input into this input string that we can use throughout our program. Then we have setup. This is setting up our port and then setting the text size in the future if we want to use like the score, and then setting the size of our window. So we just increase it to 700 by 700. And then we have void draw. So this is just checking if our port is available. We don't want to run the game if like there's no information or our port isn't actually working or there. So we set the background to this arbitrary color. And then this is how we create our basket. So what we first do is fill our, we call fill to set the color that we want to use for our next object. And then we set the variables mapped x and mapped y using the IMU_x value. So this is what we want to map. I had to multiply it by -1 because my IMU is like kind of tilted the opposite way. But if it were, you don't have to put this -1 there. It might just be like opposite. If you turn like left and then your basket will move right and then vice versa. But for now, just use like -1 times IMU_x. And then we know our range for our IMU values is -100 to 100. So that's what we put there. And then we map it to the value, the range of our screen that we have right now. And so that's from 0 to the keyword width. So this width is already set to 700 and you don't need to set it yourself. And it just takes the value over here. So width and height is 700. And then finally, we create our rectangle. This is the coordinate, the XY coordinate of our mapped value, and then our basket width and basket height. So when we run this, hopefully there's no error. Our basket should show up. Okay. Yeah, so you see how there's like an error. Sometimes I just have to unplug my Arduino and then plug it back in. Yeah, I think it's taking a while to load.
In the meantime, I think Eric was noting that he doesn't appear to have access to the skeleton code. So could that be true, or the part 1 code?
Same. It says that I need
Oh.
requests.
I am so sorry about that. Okay, I will send, I'll update right now. Share real quick. Sorry, my like laptop is really lagging today. No, I don't know why. Share. Oh, okay, that is my. Can you guys try it again right now? And like, let me know if it works.
Yeah, it's a zip file, right?
Sorry, what happened, Juan?
It's a zip file, right?
Yeah. So if you download that zip file, it should have all the parts listed, but we just kind of want to start on part 1 and then build off on that. Okay, let me reshare my screen. Okay. Okay, Everyone can see my screen fine.
Yes.
Okay, awesome. Okay, and so when you run it, you should have this. It's literally just a basket. Move it left, right, and it should move along with you. Then once you reach that part, please let me know with a thumbs up. Also, did anyone else think it was like super hot today? I'm like just sweating.
It was.
I'm like drenched in sweat right now.
I put on my official IEEE sweater before this, so I also am kind of warm at the moment.
Oh, the crew neck.
Hmm.
So yeah, I should just do left and right like this. We're almost there, everyone. Then you'll be free to eat dinner or study for midterms. Okay. Is anyone having trouble loading this or getting to this stage?
Yeah, it says there's an error. It says disabling serial event.
Oh, okay. So whenever you get the error, just like close the program, unplug your Arduino, then plug your Arduino back in, and then click on run.
All right, let me try that out.
Okay, and then let's see our next task. So after we get our controller working, all we want to do is generate an object from like our sky in our game, have it fall down, and then once it reaches the bottom, have it come back to the top again in some random position. And so what you want to do is continuously update your Y coordinate of your object as it's falling down until it reaches the height of the screen. So it goes from 0 at the top and then it slowly goes down, increases your Y value or Y coordinate until it reaches the height variable. And so let's try to do this together by just editing part 1 of our processing program. I'm trying to move this over here. Okay. So if we want to create another rectangle that's just falling from the sky, can someone tell me like what variables would I like need to add to this current program? Also, you can either type in the chat or unmute.
Would we just create basket configs but make it like rect configs or something? Like just recreate those for a different object.
Yeah, awesome. So then I'll call it object because there's like a bunch of rectangles. And then I'll do int obj width, and then let's just set it to like 20. And put that also, the height also equals 20. And then we'll set the object color to like some random number. I'll just use like 23. Okay. And then is there anything else we will need for our object? So we have the width and the height.
Coordinates.
Yes, exactly. So I'll write that down. So int obj x, int obj y. And then let's actually initialize our coordinates so we know where they should be. So let's say our x, so our x is going from left and right. Let's just put it in the center. So what value would that be? So equals to, and it's like a keyword in the program. So how can we get very close? We want the center, but we want to calculate it using a keyword. And Desmond got it. It's width divided by 2. And then let's set our y to be the top of our screen. So it's just going to be equal to 0. And then let's go back down here. So we have our we created our basket, and now we want to create object and basically update it. So how are we going to, so first we want to pick a color. So same thing as our basket, we just do fill, and then object color. And then we don't need to map anything, but we do want to update our coordinates every iteration of our draw function so that it looks like it's falling down. So how will we update object y or object x?
I don't know if I have to like subtract to the coordinate every single time that it runs.
Yeah, so we would do obj y, and then I think we can use the plus equal syntax, and then we can just increment it by like 5 each time. So like 5 pixels each iteration. And then how do we make sure that if our y coordinate reaches the bottom, how do we reset that? Or how do we check for that?
If condition.
We could just do an if statement.
And then what if statement would that be?
If I check y is equal to, I don't know, whatever the bottom is.
Yeah, so if it's somehow greater or equal to then our height, so our height is our like keyword, then we want to reset object y to be at the top. And then now we also want to pick a random position every time it's reset to the top, and that's where our random object is going to come in. So this rand, and then how you use that is setting object x. Need to open up part 2 quick. Okay. So we use this so we call the random object and then dot next int and then width plus 1. And what that basically means is it picks a random integer between 0 and width. So it's width plus 1 because we want to go from the range 0 and width. And then does that make sense how it's going to reset our x coordinate every time we hit the bottom? Okay. And then what is the last thing that we need to do? We've updated the coordinates, but we haven't actually displayed it on our screen. So what's the function that we need? It's very similar to our basket one.
We can use rect.
All right, I'm gonna put, it can be either at the top or the bottom. So then what would I fill rect with? It's practice.
Just object X, Y, and then width and height.
Okay, and then let's like cross our fingers and hope this works. But I have confidence in everyone. Okay, so the value is actually black. Actually got an error, so I'm gonna unplug my Arduino. Then we upload it. Okay, so now we can move it as our black object is kind of falling from the top. It's being reset to a random X value. But the next step is it's just falling through our basket, but we want to actually catch it as it intersects that value. So we need to kind of go back over here and check for that condition. So right now we have our object, and then we have our basket. We have our basket coordinates, and we have our object. So what is the if condition that we can use to check whether our object is within our basket coordinates or basket
They're
dimension?
equal, right? If the coordinates are equal, right?
So do you want it to be exactly equal,
No, you can
or
do
like kind of a
little
range?
bigger. So yeah, right.
All right, so let's just check like our X coordinates. So if object, and remember X is the left and right. So that would correspond to like our width, our basket width. And we can check if it's greater or equal to the minimum part of our basket, which is basket, or actually mapped X minus bas width divided by 2. And then check if it's also greater or less than or equal to mapped X plus bask width divided by 2. And then so what this is basically checking is if object, which is our object's X coordinate, if that is between our basket's width or X coordinates and the range that it takes up. So that's why we have mapped X minus bas width divided by 2, and then mapped X plus bas width divided by 2. Does that make sense to everyone? Okay, awesome. And then can someone let me know what I would do for like the Y coordinate? It should be like very similar. But if anyone wants to walk me through, it would be really awesome.
Anybody feeling adventurous?
It's like the same kind of format as this one, where you're just taking your Y coordinate up and down, or like if it's within the height of our basket.
We could always call on somebody.
So I want to put the pressure. Okay, can
I
someone? Okay, awesome.
Okay, you have to do if object Y is greater than or equal to mapped y minus basket height over 2, and object y is less than or equal to mapped y plus basket height over 2.
All right. We've got a winner. Thank you so much for sharing your answer with us. And let's test this out. So after we detected that our object is inside our basket, what do we want to happen after that? We wanted to actually, oh, sorry, good.
Oh, so I was about to say, make the object disappear.
And so we wanted to disappear and actually just reset that object back to the top. So how shall we do that? We did it a little bit earlier in the code, but we can do it.
Just reset the coordinates, right, to 0.
So odge y to 0, and then for x, what should we put for that?
Random.
Random, yeah. Okay. All right, you guys are coding masters. I might give an error again, but I'll just wait. Oh, it didn't. All right, so moment of truth. Let's try to catch. All right, great job, you guys. Okay, actually, I messed up. Okay, it's just like our basket's a little bit small. Okay, so awesome job on that. And I think our last step. Okay, so we already did this. We checked for overlap. And then finally, we want to add a score at the top of our game. And then we want to replace our object with an image. And it's actually really easy. All you have to do is call this function load image, and then the path of where your image is saved. And then this is the object p image. And this is like the same thing as rectangle, where you have the coordinates, the rectangle coordinates, and then you specify the width of your and height of your rectangle. But in this case, your image already has a width and height. You don't need to specify that. You just need to specify this image object, p image object, and then the x and y coordinate of where you want it on the screen. So let's first do this and replace our object with an image. And so I'll just look up a random image, like I'll do Bruin Bear. Download it off the internet. Oh gosh, it's like vandalized UCLA. Bear
That
I'm
happened a couple of
sorry.
years ago.
What is that?
That one happened like 3 years ago, I think, 2 to 3 years. I remember I was new at UCLA when that happened. They painted.
Oh, this is like a little monkey, like stuffed animal. Okay, I'll call it monkey.
Your permanent edition right there.
And then I'm gonna drag that. All right, so I'm gonna put that into our current folder. I think it's part 1. So I'm gonna just copy and paste it in here. So that's our current directory. Okay, so monkey.jpg. And then go back here. Okay, so we want to replace our object with an image. And so how do you think, or where do you think we would need to change the code in this program? So right now we have a rectangle, but we want an image. On which line number? What do we need to change?
I think it's year 108.
Exactly. Awesome. And so instead of this, we're going to use an image. So let's look at this right here. So can someone tell me the code that we would need to put to use the monkey.jpg?
Just image.
P image, and then what is that equal to?
Load image, and then parentheses and quotes of whatever the name of your image is.
Monkey.jpg. Okay, and then what is our last step to display the image?
Now we actually call the image command with the image and the coordinates that we want to put it at.
Okay. All right. And now let's run this. Okay, there's an error. Let me just rerun this again. And so as you can see, now we have our little Bruin bear falling down. And we can hopefully catch it with our little basket. Okay, we might need to make our basket a little bit bigger. Okay. Sorry, let me just change our basket coordinates. Let's name it 200. We'll have this 100. Oh gosh, that's kind of big. Let me make it 300. Okay, and so now we can finally catch our little image, and then we want to add a score. So how should we go about this? To just display text on the screen, we just call our text function and then specify what string and then the coordinates. So if we wanted to display it on the top and in the center, we can use this function right here. And so we want to declare our string or score. Right here as a global variable. And then down here, we want to update it in which if statement.
So inside the nested if statement.
Yep. Yeah, so this is where we detect our intersection, and then we want to increment score by 1. And then we convert our integer to a string by doing this. So this is our score string, and then plus integer.to string, and then our score. And then right after that, we want to display our text. with divided by 2, that's our x center. And then our y at the top is just like a little below the top, so it's at 30. And now let's see if we can see it up here.
Quick question, can anybody figure out why that didn't display?
Oh yes,
Quick
y
coding
is
question
our
for you.
score.
Debugging question for you. Anyone have any ideas?
I think score is supposed to be declared as it ends. I don't know. Is it declared as it ends? Wait.
I think we declared it
We
above,
have-
didn't we?
Yeah, we declared
Oh,
score.
okay, never mind. Sorry.
No, that's a good idea. But do you have any, maybe based on placement in the code, why it's not showing?
The color of the text, I believe I don't think it's
Mhm. Very nice, Desmond. Yes.
Okay.
That's the answer.
Nice catch, Desmond. Let's see. I'm sorry about that. A great catch.
That was intentional, Jackie.
Oh yes, sorry, it was the challenge. All right, so now we have our score and it's being updated. And we're basically done with our workshop. But here,
What happens if my image is a little too big?
oh, I think you can go. Do you have like a Windows or a Mac?
Windows.
I know. Well, you can try to resize it to make like the pixels like smaller, because your image is probably about the same size as your window. You can go like online. There's probably like a resize tool, and then do that. Oh yeah, also MS Paint.
So find a smaller image.
Yes. And then some extensions to this workshop that you could try on your own are, you can actually connect a Bluetooth device to your Arduino and then wirelessly communicate with your laptop, because your laptop already has like a Bluetooth like capabilities, right? And so you don't need to like communicate with your laptop using like this wire. Sometimes it's like, my wire is really short, so it's really hard to play the game actually. So you can connect like an HC05 module, which is just like a Bluetooth module to transmit information. You can actually connect two Arduinos to your laptop with an IMU to create like a multiplayer game, if you really wanted to. And then finally, you can have like a user interface to like just like control something on the Arduino rather than the Arduino controlling the processing program. But that is basically all we have today. Thank you so much, everyone, for staying the entire time. If anyone like implements like an extension, like I'll Venmo you $10 if you show me a demo. I have reached
this money, Jackie.
I've reached this point of bribing.
Secretly rich in here.
Okay, I'm feeling generous as I am graduating. I know
Question
the
though.
struggles.
Question
What
though, what
happened?
are these other parts for, like part 2, part 3, and part 4?
Oh, that's basically all we did. So that corresponds to like our exercises in the game. Like you see how this one's like exercise or part 2. This is part 3 and 4, and then this is part 4.
I see.
Does that make sense? But we
It does make
I
sense.
wanted to do it together, so like you guys had an idea of like what's going on.
That's very good. Thank you so much.
Yeah, if anyone has like any questions, like let me know, or if you have any life advice or want life advice or free resources.
Jackie has the resources.
I have if you live off campus, like in an apartment and get like financial aid, apply to CalFresh for they give you it's like an EBT card and they give you $230 each month for groceries. And I've like I would be starving if I didn't have it.
Mhm. So,
But yeah. Also if you need like we can stop the recording.